Hi guys, welcome to another tutorial. In this tutorial, I'm going to take you through 10 most useful geoprocessing applications of GeoPandas library. Now before we get started, I would like to give you a bit of a context about the data that we are going to use so that you'll be familiar with the different geoprocessing operations that we'll be doing in the next few minutes. So I'm using Spider as my Python IDE, and since we are using the GeoPandas library, also you have to make sure that you have already installed the GeoPandas library before you proceed with this tutorial. Now over here in my file explorer, you can see that I have some S3 shapefiles. Over here you can see that I have a shapefile called river and another shapefile called study area 1 and study area 2. And over here I also have a shapefile which is actually of the different states of the US. So to get started, I'm going to create a new Python script in my working folder, which happens to be this, and I'm going to right click over here and create a new module, and I'm going to name this as GeoPandas applications.py. Alright, so the first thing that I'm going to do is I'm going to import the GeoPandas library. And I would like to first visualize these different shapefiles so that we can get an idea of what sort of geospatial data we are working with. So first I would like to maybe import this study area 1 shapefile. So to import the shapefiles, I can very easily use GeoPandas library. I'm going to name this one as, let's say, study area 1, SA1 in shortened form. And I'm going to say gpd.read file, and since I have kept my Python script file inside the same folder, I'm just going to specify the name of the shapefile over here. But in case if you happen to keep your data in a separate place, you have to actually provide the full path. So that's something to keep in mind. But in this case, I'm going to simply copy this name just like this, and I'm going to say study area 1.shp, and I would like to do a quick plot in order to visualize this. Now to run this, you can either click on this triangle button over here, or you can simply hit F5, and when you do that, you can see on the right side in your Python console, you'll be able to see how the study area 1 looks. And similarly, if I were to import the study area 2, as you can see over here, I have another shapefile called study area 2, so I can simply copy this and paste it, but just change the name of the variable as well as the name of the shapefile over here. So if I run this command, now you can see that this is study area 1 and this is how my study area 2 looks. And we also have one shapefile called river over here. So let's go ahead and import that one as well. I'm going to name this one as river equals gpd.read file, and that's going to be river.shp, and I'm going to plot that as well. It's going to be river.plot, and over here you can see actually it's just a line, it's just a polyline. So this is how that river looks. So just keep in mind that this is actually how my different study areas look. But now I'm thinking that it would be convenient actually if we can visualize these different information just in one figure so that we know spatially where each of these different item would be at. So I'm going to do that using matplotlib objects. So I'm going to go ahead and import matplotlib.pyplot as plt, and then I'm going to actually get rid of this plotting commands over here. I'm just going to import the 3 shapefiles just like this, so that study area 1, study area 2 and river, and this shapefile of river will get imported. And by the way guys, if you wanted to follow along with me, you can always download this set of data from the link given in the description, so don't forget to check that out as well. And now what I'm going to do is I'm going to say figure axis, and that's going to be equal to plt dot subplots, and now I'm going to plot this study area 1 with its axis to be the same as this axis, and I would like to specify the color to be, let's say, blue, and I will say the edge color is black, so that it will create a black color outline across the perimeter of the study area 1. And I'm going to similarly say I would like to plot the study area 2 as well, but in the same axis as you can see over here. But the study area 2, I'm going to, let's say red, and the edge color I'm going to retain it as black. And finally I'm going to plot the river as well in the same axis, and I'm basically going to get rid of all of these so that the default colors will be applied for that as well. This one should be changed to edge color. And now I'm going to run this one. And over here you can see that we have the 3 different shapefiles actually plotted just in one single figure. But now you can see there is an issue. We cannot really see the full extent of this study area 1, which is represented in blue color, because that layer is actually behind this study area 2 layer. So what I'm going to do is I'm actually going to get rid of the fill color of the study area 2. So over here, instead of specifying red, I'm going to specify the fill color to be none. And then I can simply run this one. And now you can see that there are actually some common areas for study area 1 and 2 over here, which happens to be in this middle region. And over here you can see that the river is actually a line which starts from somewhere over here and ends at this particular point. Alright guys, so I took a few minutes to actually explore the data so that everything that I'm going to be discussing with you guys is going to be crystal clear to you, especially when you have a good context about what sort of data or what sort of geospatial data that we are working with. Alright, so without further ado, let's get started with the tutorial 10 extremely useful geospatial applications of GeoPandas Python library. Alright, so the first application of GeoPandas that we are going to talk about today is its ability to perform polygon intersections. To demonstrate this to you guys, I'm going to use this study area 1 and study area 2. As you can recall, this blue color area corresponds to study area 1, and you can see the extent of the study area 2 through this black color outline. So the area which corresponds to the intersection of these two will be this mid region, as you can see over here. So how can we perform that geoprocessing operation using GeoPandas? I'm going to create a new variable called intersection, and that's going to be equal to gpd.overlay, and we provide the 2 layers which we would like to intersect, and that's going to be study area 1, which is this, which we read in through this line, and next I provide the second layer, which is going to be study area 2, and then we specify how we would like to do this overlay operation, and that's going to be intersection. And after that, if I say I want to plot this intersection layer, and after that I can run, and from here you can see that we get this part which actually corresponds to the intersection of these 2 layers, which happens to be study area 1 and study area 2. Alright, let's move on to number 2, and number 2 is union of polygons. So I'm going to change this one to be union of polygons, and that's quite easy as well. I'll change the name of the variable to be union, and that's going to be equal to gpd.overlay, and the rest is going to be the same because we are going to get the union of the 2 layers, which is study area 1 and study area 2. And just over here we are going to change the method from being intersection to union over here, and after that I'm going to plot this union right over here, and after that if I go ahead and run, and now over here you can see the union of the 2 layers. Now if you would like to see how that GeoPandas geodata frame looks in terms of its attributes table, you can actually check that out from here. Yeah, this is the union, and you can see over here that it's made out of 3 individual polygons, because as you can see from the original figure, when you take the union, you'll be getting one single GeoPandas geodata frame which consists of 3 different parts. The part which corresponds to only the study area 2, and the part which corresponds to only study area 1, as well as the part which corresponds to both study area 1 and 2 together. That's why you see 3 different attributes over here in this Union GeoPandas geodata frame. And if you would like to save any of these files as an S3 shapefile back into one of your folders, you can simply do that as well without any issue. Alright, that's how we do the union. And now we will go to the third item, and that's how to obtain the symmetrical differences of polygons using GeoPandas. So over here I'm going to specify that this is going to be symmetric difference. Symmetric difference of polygons, and the corresponding or the resulting GeoPandas geodata frame, I'm going to name that as SD, and SD is going to be equal to gpd.overlay, and the 2 layers that we are going to use for this are going to be the same. And just over here we are going to change symmetric difference. After that I'm going to plot this SD GeoPandas geodata frame simply by running this script. And over here you can see the part which corresponds to the symmetric difference. So what happens in the symmetric difference is that if you come over here, you can see that this middle part is actually the part which corresponds to the intersection. And the way to interpret the symmetric difference, let's say in terms of these 2 polygons or these 2 study areas. Now if you look at this original figure of the 2 study areas, the way to interpret this symmetric difference is simply by considering the union of the 2 polygons, and if you take out the part which corresponds to the intersection, then what you're left with is basically the symmetric difference of the 2 polygons, as you can see from here. And if you would like to take a look at the attributes table, you can see that it's made out of only 2 parts. This upper part which comes from the study area 1, and this lower part which comes from the study area 2. Alright, next we'll move on to see how we can take the difference of polygons using GeoPandas. So in that case, I'm going to get rid of this symmetric part, and over here I will just retain this difference part, and I'm going to name this one as difference. And let's look at the plot of difference and see how it looks. If I run the script now you can see that when I consider the difference, again this is the original figure which corresponds to both study area 1 and 2, and this is the figure which corresponds to the difference of the 2 polygons. Now you can see that the way the difference has been calculated is simply by subtracting study area 2 from study area 1. That means when you consider this blue color area, just the part which is covered by the study area 2 has been subtracted from that, and what you are left with is basically the difference. Now what if you wanted to get the difference on the other way? Means you wanted to minus out the part of the study area 1 from the study area 2. Well, all you have to do is to switch these 2 up. Instead of keeping study area 1 on the left side, what I'm going to do is I'm going to keep study area 2 on the left side, and I'm going to minus out the part which corresponds to study area 1 from the study area 2, just like this. So I flip these 2, and if I run the command now, you will see that the difference that I get is basically this white color region of the study area 2. Yeah, it's just as simple as that. Alright, now we'll move on to the 5th geoprocessing operation, and that's how to use the dissolve geoprocessing operation using GeoPandas. So I'm going to comment that one out. Alright, so what does it mean by dissolving a polygon? To explain this, I'm going to first create the union. Again, gpd.overlay, study area 1, study area 2, and how by union, and after that I can plot this by taking union.plot, and if I run this, you can see that now we get the union of this study area 1 and study area 2. But as you can see over here, this union is actually made out of 3 individual polygons. But let's say if you wanted to merge these three polygons so that instead of having three different attributes, you will just have one single attribute which happens to be just a complete polygon like that. That's actually one of the examples of dissolving polygons. Now, in order to do that, in the attributes table, you need to have a column which contains a common value for each of these three polygons, as you can see over here. So what I'm going to do is I'm going to open up the attributes table over here for a second. And if you want to dissolve something, as I mentioned to you guys, I need to add some sort of a common column so that I can perform the dissolve operation based on the value of that particular column. But as you can see over here, I do not really have a column which contains a common value. So what I'm going to do is I'm going to go ahead and create a column called, let's say, common col, something like common column. Actually, the name doesn't really matter. It just needs to be a random column, and you just have to make sure that that random column has the same value. So either you can just pass a string over here, doesn't really matter what you enter, or you can just specify a number so that that particular value will get added into all of the different attributes of that particular GeoPandas geodata frame. So let's go ahead and execute this command. And after that, if I check the attributes table of the union GeoPandas geodata frame, now you can see that each of these three polygons have received a value of 1, which is actually a common value to all these three attributes. And now we can utilize this common value in order to perform our dissolve operation. So what I'm going to do is I'm actually going to copy this one because I would like to execute it right over here as well. And after that, I will say that dissolved study area is equal to union dot and we are going to dissolve this by the common column which happens to have the name common column as well. And as I told you guys, again, we don't really need to have this same name over here. It can be just any name which contains a common value for the different attributes which you would like to merge together. And I can run this. Well, and after that, I can simply plot dissolved study area dot plot, and now you can see it's just a continuous polygon which happens to be an aggregation of all these three different polygons together, because we did take the union and we actually dissolved it based on a common column. And now even if you open up the attributes table which corresponds to this dissolved study area, you can see that now it contains just one attribute, and that happens to be this entire area which gets covered by study area 1 and study area 2, just like this. Alright, so I hope you guys got the idea of using dissolve geoprocessing operation using GeoPandas. And now we'll move on to the next geoprocessing operation, and that's how to create a buffer. Alright, so to demonstrate this to you guys, what I'm going to do is I'm going to actually use this line or this river shapefile or this river GeoPandas geodata frame that we have over here. And I'm going to create a buffer around this line for a certain distance. I'm not sure, maybe about 500 meters of a buffer, so that it creates a polygon around that specific line, demarcating that buffer, which extends 500 meters further away from the line for the entire stretch of the line. So now we'll see how we can do that. And before I proceed with that, I might need to actually check a few things. For example, first I would like to see what the coordinate reference system of this river shapefile is. So what I'm going to do is I'm going to say river, and if I say CRS, over here I can get to know the fact that over here my coordinate reference system is EPSG 4326, which corresponds to the geographic coordinate reference system. And since I'm going to deal with meters when I'm specifying the buffer zone, I would actually like to change this coordinate reference system from being a geographic coordinate reference system to a projected coordinate reference system. And this area is actually corresponding to one part in Malaysia. So what I'm going to do is I'm going to use one of the projected coordinate reference systems used in Malaysia by making use of its EPSG code. And I'm going to first transform the coordinate reference system from this WGS 1984 geographic coordinate reference system into a projected coordinate reference system. So the first thing that I'm going to do is reprojecting the river GeoPandas geodata frame into a projected coordinate reference system. So you can simply do that by specifying river dot to CRS, and over here I'm going to specify the EPSG code, and the EPSG code of the corresponding coordinate reference system for this part of Malaysia is 24547. But in your case, if you're actually doing this for a different part in the world, then I think you might be able to very easily find what the corresponding EPSG code of that particular projected coordinate reference system, and from there you can actually first do this conversion. And I'm going to make this one equal to a new file called river projected. First let's run this one and see how it looks. Here, after I run this one, I can first plot the previous river geodata frame, and you can see the XY coordinates are actually in decimal degrees. And now if I go ahead and plot the river projected geodata frame, now you can see that the XY coordinates have been changed from these values to be in meters, as you can see over here. Well, you'll be able to see that from this attributes table as well. Under this geometry column, you can see that these items in this line string are basically in decimal degrees, but in the river projected, you can see that these items are now in UTM coordinates, which happens to be in meters. And the other thing that you need to keep in mind when doing the buffer operation is that you can perform the buffer operations only on GeoSeries. Now the difference between the GeoSeries and the geodata frame is basically that if you take this entire thing, it's actually called a geodata frame, a GeoPandas geodata frame. But if you just consider this geometry column without everything else, then actually it happens to be a GeoSeries. For example, you can check the type of river projected, and you can see over here it's GeoPandas geodata frame. But if you take only the geometry column of river projected, from here you can see it's a GeoSeries. So we are going to perform this buffer operation on this GeoSeries. So I'm going to simply copy this one and paste it over here, and I'm going to name this one as buffer, let's say 500 meters. That's going to be equal to river projected and its geometry column dot buffer, and we can specify the distance to be 500 meters. And after that, I'm going to ask the program to plot. Well, first let's run this one and see what happens. Here you can see that the command ran without any issue. So now I'm going to again plot the river projected first, and after that I'm going to plot this buffer 500 meters, just so that we can see the difference. And over here you can see that now the river stretch has been actually expanded using this given buffer of 500 meters. Well, if you would like to enlarge this, maybe we can increase the figure size to be about 10 or maybe 7 by 7. And now you can see that a bit more clearly, where this is the buffer zone which corresponds to that particular line that we had before, with a buffer distance of 500 meters. And you can do this for polygons and even points, depending on your specific case. But the method that you have to follow will basically be the same, as you can see over here. So now we'll move on to the next geoprocessing operation, and that's actually how to obtain the centroid of certain polygons. Alright, so I'm going to get rid of this one, and similar to the buffer operation, we can obtain the centroid, but we have to make sure that we are executing this on a geoseries instead of a GeoPandas geodata frame. So to demonstrate this to you guys, let's see that maybe I think I might go with the union again, because once I get the union, I will actually get 3 different attributes, which means 3 different pieces of polygons, as you can see. And after that, I will try to see if I can get the centroid of each of those polygons in the form of a geoseries again. So first I'm going to create the union, similar to what we did before. Going to overlay GPD1, overlay SA1 and SA2. And how we are going to do that is by taking the union, and I will plot just to make sure we get what we want. And as you can see over here, it's made out of 3 different polygons. Maybe when I plot this, I can specify the edge color to be something like black, so that you guys will be able to see the boundary of each of the polygons, each of the polygon attributes, as you can see over here. Now, if I were to get the centroid of each of these 3 different polygon attributes, I can get that simply by creating a variable. I'm going to create a variable called centroid, and that's going to be equal to union, but again we are going to consider the geometry column of this union GeoPandas geodata frame, so that this particular thing that you see over here will be a geoseries. And from here I'm going to create the centroid. Yeah, after you run the command, we can actually plot this centroid over here and see how it looks. Yeah, as you can see over here, the centroid of course happens to be just a point. So this is how the 3 points actually appear. So this first point that you see over here should be the centroid of this particular polygon. And the second point that you see over here should be the centroid of this second polygon attribute over here. And this third point is actually the centroid of this third polygon attribute that you can see over here. I think it would be quite clear if I were to plot these 2 again in the same figure. So let's go ahead and maybe do a quick visualization. I'm going to create, so since I'm going to plot 2 different things, I'm actually going to create something called the figure 1 and axis 1, and over here the 2 things that I'm going to plot are the union and the centroid. And the centroid will be actually on top of the union, and of course I need to change the axis to be axis 1 over here in this case. And for the centroid I'm going to change the color to be black, and there will be no edge color over here. Yeah, we'll see how this appears. Yeah, now you can see that this is how the centroid actually appears for each of these polygons. So the centroid of this upper part of the study area is this intersected part is this dot, and this part of the study area too is basically this point that you see over here. I guess that's clear for you guys. Alright, let's move on to the next geoprocessing operation using GeoPandas, and we are going to discuss how to convert a given set of XY coordinates into point geometries using GeoPandas. So I think I won't be needing any of these items anymore, so I'm just going to go ahead and take them out like this. And the list of points that I'm going to use for this task is actually coming from this CSV file that you see over here, which I downloaded from kaggle.com, which lists out different airports in the United States. We have something like a code over here, and we have the name of the airport, the city, the state, and the country is USA, we have the latitude and the longitude information. And I'm going to use GeoPandas to actually convert this information into a set of point geometries so that we can visually see where exactly each of these airports are located at. Alright, so just keep in mind that this particular CSV file is located inside our working folder. So I'm also going to use pandas to first read in that CSV file. So I'm going to first go ahead and import pandas as PD. And if I open up the file explorer over here, you can see that I have that particular CSV file over here, which is this US_airports. So I'm going to create a variable called airports data, and that's going to be equal to pd.read CSV. Now we are using the pandas library, and again, since this file is located inside my working folder in which I have saved my Python script, I do not really have to worry about specifying this full path. I can simply say US airports.csv, and after that I can run the command, and now if I check airports data.head, maybe we'll call for the first 10 items just to see whether the data got imported properly or not. And now you can see that the data is actually already here, and we get to see the different columns of this airports data pandas data frame simply by saying columns, and you can see the different columns over here as well. And now what I'm going to do is I'm going to make use of this latitude and longitude information to create the special geometry column, which is an essential item which we need to have when we create a GeoPandas geodata frame. So I'm first going to create the corresponding geometry column, and to create this geometry column, I'm going to import one more library called Shapely. Well, what I'm going to import is I'm going to import from shapely.geometry. I'm going to import point so that I can use that in here. This is going to be point xy for xy in zip, and we are going to use the same data that we imported over here, but not really the entire pandas data frame. We are going to use the longitude by selecting that column, and in addition to that we're going to again use the latitude information. I'm just going to copy and paste it from these column headings, as you can see over here, and then let's run this one and see. Yeah, now if you would like to check the type of this geometry, you can see that it's actually a list, and you can even have a look at the items as well, as you can see over here. And now what we're going to do is we are going to actually embed this in a GeoPandas geodata frame. So the way to create a new GeoPandas geodata frame is similarly by assigning the variable name first. I'm going to name this GeoPandas geodata frame as airports_US, and that's going to be gpd.geodata frame, and I'm going to use the same pandas data frame that we used over here, and we need to specify the geometry column, and I'm going to assign the geometry column to be this list which we created over here. And finally I need to assign the CRS, and the CRS is going to be, let's say if I wanted to use the CRS from one of these existing shapefiles that you can see over here. I have one shapefile of the different states of the US. So what if I use the same CRS by first importing this shapefile over here, and then we can check the CRS of this shapefile, and we can directly assign that CRS to be the CRS of this new GeoPandas geodata frame which we're going to create right over here. So for that, over here, let's go ahead and first import states S3 Yeah, I'm going to create a variable called US states, and that's going to be equal to gpd.read file, and that's simply going to be this usstates.shp. Yeah, if you happen to run this one in your console first, so that you can do a quick check, and if you happen to check the CRS, you can see the CRS is actually EPSG 4326. So what I'm going to do is I'm going to assign the same CRS of this particular shapefile, or this particular GeoPandas geodata frame in this case, simply by saying that take the CRS of this US states GeoPandas geodata frame. Yeah, that's an easy way to avoid typing out this right here, so that it'll directly extract that CRS from this existing US states geodata frame. Yeah, after that I can run this one, and as you can see it took about 2 seconds to run that command. And now if I wanted to plot this airport US dot plot, you can see that now the point geometries get plotted just like this. Now you can always go ahead and inspect the attributes table. We can go to this airports US, and over here now you can see that all of that information have been imported into this attributes table along with this special geometry column, which actually makes it possible for us to plot this on a map just like this. And of course, if you would like to reduce the marker size, you can do that as well. But as you can see over here, now we've successfully managed to import a set of XY coordinates into Python, and we managed to create point geometries using GeoPandas by making use of those lat-long information. Alright, let's move on to the next geoprocessing task that we are going to talk about today, and that's how to perform attribute joins using GeoPandas. Alright, so to demonstrate to you guys how to perform an attributes join using GeoPandas, I'm going to use two files. First, I'm going to use this airports US GeoPandas geodata frame which we just created. So if I wanted to have a look at the attributes table, you can see that the items that we have inside over here, we have this IATA code, we have the airport name, the city, the state code, the country, the latitude, and the longitude. I have another CSV file which contains the state code and the actual name of the state. So what I'm going to do is I'm going to use GeoPandas to actually merge these two layers in a way that I would be able to transfer this state name correctly as a new column into this GeoPandas geodata frame based on these two columns, which actually consist of the state code. Now in order to do that, you have to make sure that you actually have the same heading for the column by which you're going to perform this attributes join. So what I'm going to do is I'm going to first import this state names and codes CSV file, and after that I will go ahead and change this name of this column from being state to state code, so that we have the heading of the two columns to be exactly the same. Alright, so first I'm going to import this CSV file, and to do that we can simply use the pandas library. I'm going to create this variable called state names codes. That's going to be equal to pd.read CSV, and that CSV file is actually located right inside here, this file. So I'm going to copy the file name and paste it over here, and after that I'm going to run the script. And now if I check the first 10 items, you can see that the items actually got you can see that the CSV file got imported without any issue. And the next thing that I'm going to do is I'm going to take this airports US and I'm going to change the column name from being this state to this state code. So this is going to be renaming the column heading, and that's going to be airport US dot rename columns. The original name is state, and I'm going to rename it with this name right over here, and I'm going to say in place equals true just to make this a permanent change. And now we can simply run this and we can see this airports US dot columns, and now you can see that the state has been changed to state code. You can see that from here as well. And now you can see that this, what was initially state, has now been changed to state underscore code. Alright, now I think we can go ahead and perform the attributes join. And we can do that attributes join simply on this airports US GeoPandas geodata frame, and that's going to be equal to, again, airports US. I'm going to put this on the left side of this merge operation, and on the right side I'm going to specify from which pandas data frame I'm going to extract the corresponding information, and I'm going to perform this merge operation on the specific column name, which happens to be state code. And after that we can hit run, and now if I open up this airports US GeoPandas geodata frame, you will be able to see that we managed to extract this particular column from that pandas data frame, so that you can see what is the full name of the state which corresponds to this state code that you can see over here. So in this case, this NM corresponds to New Mexico, TX is Texas. Similarly, you can see that WA is Washington, ND is North Dakota, just like that. You can see that the attributes join happened perfectly with no issues at all. Alright, so now let's move on to the final geoprocessing operation that we are going to discuss today in this tutorial, and that's how to perform spatial joins using GeoPandas. And first of all, I'm going to get rid of all of these, which I did to demonstrate to you guys the attributes join operations. And for this, I'm going to be using this usstates.shp shapefile. So I would like to actually plot this right over here as well. And if you see visually, this is how that shapefile looks. And we can have a look at the attributes, the individual attributes as well. So if I check the attributes, maybe the first 15 attributes. And over here you can see in terms of the attributes, we just have two columns over here. We have the name of the state and we just have this spatial geometry column. Right, for this I'm also going to do a bit of cleaning up of this airports US GeoPandas geodata frame over here. Now you can see that we have actually quite a number of columns over here, but let's say in case if we happen to have just only the airport name and this geometry column. So I'm going to extract just those two columns. I'm going to take only this airport and this geometry column. And we can go ahead and run this. And now if I check this airports US, you see that we only have this airport column and this geometry column. And just because I retained this geometry column, it actually didn't lose its geometrical properties. Now, even if I simply say airports US dot plot, you will see that we are still able to plot these two together. And just for the purposes of visualizing, let's go ahead and visualize these two together as well. So I'm going to create the figure and the axis, and that's going to be plt dot eight by 8. And now I'm going to plot first the base layer, which is going to be this US states dot plot, and over here I'm going to specify the axis to be equal to the axis, and color will be blue, and the edge color will be black. And similarly, the airports US, I'm going to put them in the same axis. And now we'll see how this looks. We managed to plot these two together, but of course we need to make some changes. But I think I can reduce the marker size to be about, let's say, 2, and the color to be, let's say, green. Yeah, even though it's not so clear, the individual points, because we have actually quite a number of points, you can see that the two layers have been plotted on top of each other. You can see that the airports US layer has been now plotted on top of this US states layer. So what I'm going to do in order to demonstrate the spatial joins is basically based on the spatial location of each of these airport, I'm going to extract the corresponding state. So in this case, we are not going to do any attributes join. We are going to extract the information from this US states base layer, in which we have the name of the state, and we are going to plug them in to this airports US layer so that we can see as a new column in which state each of these airports are situated at. Now for your specific purpose, it could be a different case, but of course you can apply the same concept in order to perform a spatial join, and the spatial joins are completely dependent on the spatial location of each of the different attributes. So now let's go ahead and perform that spatial join. So I'm going to use the same layer, airports US, and I'm going to make it equal to GeoPandas spatial join, sjoin, and the things that I'm going to join are this airports US layer with this US states layer, and over here we have to specify two arguments. The two arguments are how and this OP argument. So what basically this how refers to is that the way you need to specify your indexes. Now let's say if you specify the how argument to be left, then what happens is that it'll use the index from the first or the left geodata frame that you have provided over here. In this case, that's going to be this airports US, and it'll retain only the geometry column of that particular layer. But in case if you happen to provide the argument to be right, in that case it's actually going to be this particular layer, and it'll be using the index from that layer, and it'll retain the geometry column of that layer. But in case if you use the argument to be inner, in that case it'll actually use the intersection of the index value from both geodata frames, and it'll retain only the geometry column of the left layer that you have specified over here. So for this case, I'm just going to go with inner, and Over here, we also have to specify this OP argument. Let's say if I specify the OP argument to be intersect. In that case, the attributes will be joined if the boundary and the interior of the object intersect in any way with the boundary and the interior of the other object. So for this, I'm also going to go with intersect. Let's see how it works out. So now I think we can just go ahead and run this command. Yes, as you can see over here, the code ran without any issues. So we'll open up this airports US GeoPandas geodata frame, and now you can see that it extracted the corresponding state name from this base layer and plugged that in over here so that we can see where in which state each of these airport is actually located at. And this happened completely based on the spatial location of each of the attributes. That's the most interesting part. Alright guys, that brings us to the end of this tutorial. We discussed quite a lot of things pertaining to the applications of GeoPandas library using Python. And if you do have any questions regarding this tutorial, don't forget to comment them down below. And if you did enjoy the tutorial, don't forget to show your support by hitting that like button. And also, if you would like to see interesting tutorials like this in the weeks to come, you can consider subscribing to this channel as well. Thanks a lot for watching guys. I'll see you in the next one.